Good morning, everyone. Thanks for joining us for this Introduction to JIRA Plugin Development webinar. We'll be recording this session and we'll submit a link to the recording over the next few days. Just a quick note, our next webinar, JIRA Confluence Integration Primer by Charles Wells, is planned for April 2nd at 11 a.m. Central. If you have any questions, please be sure to provide them in the questions utility found in the GoToWebinar control panel. We'll queue them up and answer them towards the end of the session. On the phone today from Precipio Consulting, we have Christopher Pepe. Christopher heads up our Atlassian practice. He's been working with the Atlassian products since JIRA's initial release in 2004. And I'm Shayla Sander. I head up business development for Precipio Consulting, and I'll be serving as a moderator for this webinar. We've been Atlassian experts for over 5 years now and are one of 5 platinum enterprise experts in the country. Over 98% of our projects are Atlassian related, and we have over 100 clients across the United States, ranging from small 20-person startups to Fortune 20 size enterprises across many different industries. We help our clients with process-centric technology solutions that facilitate traditional business process management, IT service management based on ITIL, and software development life cycles. In the SDLC space, we're helping clients transition from traditional waterfall to agile, and whatever widgets you produce, we can help improve the quality and throughput at the lowest cost. As Atlassian experts, we support our clients in all facets of the Atlassian product suite and build methodologies and solutions across the entire line of products. Solutions architecting and implementations, licensing, installs, upgrades, and maintenance, hosting and managed services, and we also offer training and custom development. So with that, I'm going to go ahead and turn things over to Christopher Pepe to lead us through the webinar.
Great, thanks, Shayla. Let me just promote myself to presenter here. Great. So if any of you have ever tried to watch a video in a webinar, you probably know it's a pretty painful and terrible process. So I'm not going to bother playing the video for you. If you're interested in seeing this thing in action, if you just search for Me JIRA in your favorite search engine, there'll be a link to a YouTube video that should be up near the top somewhere. So I'm going to launch a poll right now, and we're just curious if any of you are planning to build a add-on in the next few months, and if you are, for which product are you planning on building it for? So let's give you a second to vote there, if you would. Great. Still looks like mostly JIRA, which is probably what we'd expect. That's interesting. We got about just half of you voted now. I'll give it just another second. Cool. So it looks like half of you are planning on building a JIRA add-on, and then Confluence, Dash, and Bamboo are all about 20%. So that's really great. I'm glad to hear that. So definitely, if you have any specific questions about add-on development, please feel free to put them into the question box so we can try to address them towards the end. If they're really specific, like I'm trying to use this particular API and I'm getting this error, those are going to be hard to answer in this kind of format. But definitely any question you have, feel free to ask it. All right. So we're going to talk about the actual hardware. How do we build a controller to pour beer? And we're going to take a look at the add-on itself, so all the different components within JIRA that one control the hardware, which in turn pours the beer, as well as the other pieces that we integrated into the workflow and other parts of the process that we put in place so that you could go through the experience of pouring a beer, rating it, performing QA on it, which is pouring you another beer, and some of the other little things that we put in there. And then lastly, we're going to take a look at just really high-level JIRA add-on development. And then if we have time, we can dive into anything else that you're interested in. So first up is the hardware. One of the main goals for this was every time I walked into a room, people would say, "Hey, look, it's the toaster guy." So I wanted to come up with a follow-up to that. That was a really popular thing that we did, and under the covers is actually a really simple and very silly little thing. The actual JIRA to toaster integration was trivial. Reverse engineering the PDU and building a controller for it was infinitely more difficult than the actual integration. So I wanted to do something that was cooler, more flashy, also more kind of more technically interesting than that particular demo was. So we decided to do it for Summit, and we wanted to give away beer, and we finally got the approval to be able to actually pour beer at Summit. So that was great. So really the two main things we needed to do was be able to control the size of the pour, and then validating the drinker's age. That was the two things we had to do. So we used the time-honored honor system for letting people self-report their age as the legally binding way of validating their age. And then I just threw in, I wanted to add in a bunch of other add-on modules just to show the different things that you can do with JIRA and how easy it is to create different modules. So I've got links to the design and the setup. I think we'll skip over them though. They're not particularly interesting. I'll just talk to them at a higher level. So we went back and forth on designs for quite a while. I thought of a lot of different ways that we could implement this, and ultimately settled kind of on this design. So if you've ever made your own beer or worked in a bar or anything like that, the way that the magic actually happens when you pull on that tap handle and beer comes out, it's a really simple system. So we're just looking at the far right-hand side right now. You have a CO2 tank, which goes into a keg and pressurizes it. And then you have another port where the beer actually comes out. And you take that line that comes out of the keg and you just hook it directly up to the tap where it says no, but it's actually normally open is what that NO is standing for. But that line would skip over the little solenoid that's there and go straight to the tap handle. And then you have a tap handle you pull forwards or backwards to turn the beer on and off. And that's really the whole system. All you need is one person to just pull that lever and pour the beer. So we figured, let's make this infinitely more complex and remove that person, but still need to have people standing around the thing. So the way that we did that was we put together this whole set of hardware. In order to actually pour beer, we needed to take the tap handle, which you usually use to control the flow, and pull that forward and leave it in the open position, so the normally open position, so the beer could flow through it. And instead, we moved that check valve to an electrical solenoid. That's the 12 volts that you see there. It's an electrical solenoid that when you energize it, opens up a flow valve, a check valve. So that would then allow the beer to flow through and into the cup. So everything that's to the left of that is all just control circuitry to make that happen and give us a mechanism that was easy to hook up JIRA to be able to control that. So I'm going to start at the left-hand side. The very first thing that we have is a little Wi-Fi dongle, which connects to a Raspberry Pi over USB. So Raspberry Pi is a small embedded computer. I think it's an ARM-based architecture. There's a really big open source community around it. There's a lot of different versions of Debian that run on it. It's got USB and VGA and Ethernet, and then these general purpose I/O pins. All kinds of really cool stuff, and they're like $30. So it's a really awesome little embedded system. It's really easy to put together a control system with. So I had debated building something from the ground up, and then ultimately decided this was a lot cheaper and faster. We supported 2 beers. We actually only ended up pouring 1, and we could do up to 16 pretty easily. But most of the code and everything that I have in here is designed to support 2 different beers. And because ultimately what we're going to do is turn a valve on or off, we really just need 2 bits to do that. So for that we used 2 general purpose I/O pins. It actually looks like a GP10. It's supposed to be GPI. So those are general purpose I/O. And we're setting them both as outputs. So we used pin 10 and pin 12. There wasn't really a pull-up resistor there. I just wanted to show that the Raspberry Pi logic level is 3.3 volts. So I used a logic converter to step that up to 5 volts. So that's the V++. So the way that binary works, if you don't know, is that your 1 translates to some voltage and your 0 translates to ground. So when we drive this pin high, the Raspberry Pi puts out a 3.3 volt signal, but what we want is a 5 volt signal because our relay runs on 5 volts. So in order to turn on the solenoid valve at 12 volts, we use the 5 volt relay, which can handle the bigger load and allows us to toggle that. And then there's actually a transistor that's not shown in here between the V++ chip and the 5 volt relay. And that was an NPN transistor, so it actually inverted our logic. So really what we would do is drive a pin high to turn the solenoid off and drive a pin low to turn it on. I think that was how it worked anyway. It ended up, there are so many different places that you can invert the logic that we just set some values, and if it didn't do the right thing, we flipped it around. So the whole idea here is that then now over Wi-Fi, we're going to be able to send some sort of a command which is going to open up this valve. So how we decided to let JIRA be able to control this hardware was by putting together a REST service. So that's a very web-oriented technology. There's a lot of REST services that are already built into JIRA, and that's kind of the main integration point that we use with a lot of other systems. REST is really popular because we can do things asynchronously behind the scenes. So we don't have to migrate away from or navigate away from the page that we're on. We can go off, call some REST service, get some information, and then update the document that the person's looking at in their browser instead of having to reload the page. So REST services are really popular for that. And it's a really easy way to integrate into JIRA. So that's what we decided to do. So I used WebPy, which is a Python web framework. It's a very lightweight framework. It's already available for the Raspberry Pi, so it's easy to get it and all of its dependencies in place. At the very last minute, I threw in an access control list because I realized that we're just running our Raspberry Pi on a public network at Summit, and there's no authentication. It's not running over SSL or anything like that. So any kind of networking or IT geek could pretty easily figure out what the commands were that you needed to run and then go and pour rogue beers and just turn the thing on. So I put in just a little ACL check just to prevent the easiest case. You can still get your way around it if you really needed to, but it would prevent most people from going out of their way to cause beer to pour on our feet. We needed a way to actually do the pour itself, so when you call this REST service, that it goes and actually controls the hardware and drives the I/O pins correctly to pour some volume of beer and then just return back. So if you look at the light class, we'll actually use that. Well, we'll use the dark class because that's what's in the URL here. So if you look at the dark class, the one at the top, it's defined as a HTTP GET, and it expects a parameter of a volume. And we do the access control list check, and as long as you're on the ACL, then we call this beer control object and tell it to pour dark beer of some volume. So over on the left-hand side on the board on the bottom, that's the actual URL that you would hit in order to invoke this particular class. So beermejira.local or whatever your Raspberry Pi is named /dark/2. That's going to call the dark REST service, and it's going to send the parameter of 2, which is going to equate to 2 ounces for us. Then we need to take our beer control class and take that information and do something with it. So we did all of this in Python. The Raspberry Pi is very Python oriented. It's already got a hardware control set of modules that are available for it. So the very first import you see is the Raspberry Pi.gpio. So that's our general purpose inputs and outputs, and that's just a control library that allows us to manipulate all of those I/O pins. A kind of a side note here, a long time ago when I used to be an embedded systems engineer, we did almost everything in C, and I ended up writing a similar type library for our hardware stack that allowed you to write Python scripts that manipulated the hardware. If we were making like a robot, like a line running robot or an articulated limb robot or something that was using neural networks, we would have much tighter control loops. We would need much faster control. So we probably wouldn't do it in Python. We would probably do it in a lower level language where we could be a lot more efficient and have a lot better control of time. But what we're doing here is just opening a valve and pouring for some number of seconds and then closing it. So this is plenty fast enough. And this is a good, easy way to get into embedded development because you get to program in a comfortable, high-level language without having to know a lot about the real low-level intricacies of using different masks and two's complements and all that stuff. So we have this beer control class, and you can see in the initialization of it, we define a light I/O and a dark I/O, and that just allows us to point to the specific I/O pin. So if we end up needing to use a different I/O pin, or if we wanted to add more beers in here, we can easily just map them back to the physical pin on the Raspberry Pi that we're plugging in our control line to. So what we're going to do is to pour a light beer. We're going to take pin 10 and drive it high or low. The other thing was in my original design, I'd put a flow meter in line with the beer so we can actually measure the beer going by. You know, we know the cross-sectional area of the beer tube, and we can measure the flow rate, so then we can get a mass flow rate out of that, and we can calculate volumes very accurately. But it turns out that flow meters are just stupid expensive, and I didn't want to spend another like $300 or $400 on this. So instead, what we decided to do was just do a timed pour. So in a very similar vein, we can still get a very accurate pour by timing it out. It just would take a little bit of tuning in order to get the volume correctly. So the pressure that your CO2 tank is at, and the length of your beer tube, and a number of other different factors affect how the beer actually pours. So this size conversion allowed us to keep the pouring valve open longer or shorter. So we set it to 1.0, and we tweaked it from there. So every time you set this thing up, you have to go and actually tweak that parameter. And then there's just some other setup stuff where we're telling it to make them all output pins and stuff. And if you look at pour light down at the very bottom there, you can see it takes a volume as well. So if you remember, here we said pour a dark beer of volume 2, and here we'll pretend that we're pouring a light beer instead because I didn't show the dark code. It's exactly the same. So we take that volume of 2, and the very first thing that we do is we drive our light beer pin high, and that's going to start pouring the beer. It's going to open the valve and allow the beer to flow since it's pressurized. And we're driving the dark I/O pin low here as well, or turning it off. Not strictly necessary, just doing that to ensure that we don't pour 2 beers at once. It turned out that if we opened both of those relays at the same time, that causes big power fluctuation, which caused the Raspberry Pi to reset. So rather than actually fix it in the hardware, I just made the decision that we'll only pour 1 beer at one time. So it's kind of a slow process anyway, though it should be fine. So it's worth noting from a software development and design perspective that this is not thread safe. This is not multi-user. So we're using a multi-user technology. We made a website, with REST endpoints or just cleverly crafted URLs that you hit in order to control this hardware. So that's a multi-user environment. But here, our actual control code in the embedded system is not multi-user. So that's something that you have to be really conscious of when you make these kind of design decisions. You need to put something in place to ensure that only one user is going to use it at any given time. All right, so we drive our light beer pin on, so actually low in our case, but it doesn't matter. We turn it on, and then we go to sleep for some amount of time. The volume times the size conversion. So the volume was 2, our size conversion is 1, so we go to sleep for 2 seconds. If our pressure was really low, then maybe our size conversion would have to be 1.5, and we would go to sleep for 3 seconds instead. But whatever the time is, we go to sleep for that amount of time, then we turn our light beer off by toggling the pin. So again, all we did to control our beer was we drove a I/O pin on, and then we drove it off after sleeping for some period of time. That caused the logic pin to drive high, which triggered the NPN transistor, which turned on the relay, which hooked up the solenoid between 12 volts and ground, so it allowed electricity to flow through that coil, which then activated the solenoid check valve and allowed beer to flow through the system. So that's how the whole thing works, if you followed any of that. Now let's take a look at what we did in JIRA. So now we actually have a control system here where we can go and hit a URL, and that's going to cause beer to pour for some period of time. So now how do we take that and actually hook it up to JIRA? The very first thing that we need to do is ensure that we have a process in place so that people can go and safely pour a beer, but it's not going to just start pouring unexpectedly. The way I decided to do that was by flashing a warning. So when you click on the pour button, it's actually going to flash up a warning that says you need to make sure that you have got a glass underneath the tap. I decided to implement that as a custom field. And because all it's doing is just displaying a message, there's no Java code that goes with it. It doesn't have to do any processing or anything. So I didn't put what the stub Java code looks like here. All I did was I went into the Atlassian SDK and I created a new custom field module within my VirMe plugin. What that did was it modified my Atlassian plugin.xml file. That's my plugin descriptor. So it's got all the different modules and all the different components that I'm creating listed out so that Maven knows how to build and package up my Atlassian plugin and puts everything in the right place so that JIRA can then in turn use it and figure out what to do with it. So if you look in the top left corner, this is the little bit of XML that gets put into the plugin descriptor to define all the different aspects of this custom field. It has a name, that's edit message field. It's got a key associated with it. Really the only thing to pay attention to are the two resources at the end, those two velocity templates. So we have a view template and an edit template. And when you're viewing a screen that has this custom field on it, there's nothing that I want to display. So my view template is empty. My edit template is just a little bit of HTML, which creates a red div, and it's got a H1 and an italic bit that displays this message. Be sure the glass is under your tap, or it's going to get messy. So the cleaner way to do this would be to have a little robotic eye that actually validates there's a cup there and doesn't pour unless it's there. But that doesn't let me get to show off the plugin SDK, and it's more money and more complex to build all of that hardware in. So next up, we needed a reason why people were getting beer, right? If you just want beer, then you just need a person to pull the tap handle and pour the beer. So we, being a process company, said we need to do something so that there's a reason for people to go through a couple of different steps to go pour a beer. So what we decided to do was a rating system. So we just created a custom field called rating or something like that had values of 0 through 5. We could have made it really flashy and made it just like a little clickable thing instead of just being a select list, but we went with a select list because it was easy. So when you wanted a new beer, you would create a new ticket, go and pour the beer. There's the option to QA, which means you just go and pour another beer. And then once you're done, you can rate it and then close the ticket. So we built a little gadget to put on the dashboard, which went through all the different ratings that people had created, averaged them up, and showed what the average rating for that given beer was. So that way we could see, do people like the dark beer or the light beer more? Did I hit all those points? I think so. So the way that we actually implemented this was we made a REST resource. Part of our REST service was a method that you could call that would go through and actually ran a JQL filter to get all of the different beer tickets, and it would go and grab the rating field out of it and then just calculate an average. So add them all up, divide by the number of entries that there were in there. So again, in order to create a gadget, we had to go to our SDK, tell it to make a new gadget module for us. You can do all this stuff by hand, but it's a lot easier to use the SDK. So that threw some XML into our Atlassian plugin.xml file. So we gave the gadget a name and a description. You point it towards the XML file that actually describes the gadget itself. So it's got some JavaScript in it and some other things that define what does the gadget do. JIRA and Confluence, and I think even Embedment, all the tools, they use a standard called OpenSocial. It's an XML file and then some HTML and CSS and JavaScript that defines what your gadget actually does. So it's just an open standard that's out there on the web, and there's ways of creating them. So you just define what your OpenSocial gadget looks like, and then it can be used within JIRA. I said we made this REST resource to be able to calculate the average, so I had to actually also add in a REST module using the SDK as well. So same sort of thing. You point it towards what's the URL that it's going to show up at, and where do I find the Java file that goes along with it. On the right-hand side here, you can see a little bit of the code. What we do is we go and we run a query. So we have query result.getQuery, and it goes through and gets all the issues that are returned by a particular JQL query. And then we just iterate over that list of issues and get the values out of them and add them all up and then divide them so that we can calculate the average. So here again, in order to create our gadget, which displays the average rating, we needed to create the gadget itself so that we could display the information somewhere, and then a REST resource to go and actually calculate that average value and return it. Next up, we wanted to add some controls into the workflows. We're a process company. Most of the work that we do with our JIRA clients is helping them develop workflows to facilitate whatever process it is that they are trying to enforce with JIRA. So a lot of times that means that within the workflow, we create a custom workflow so you have all the different steps that you're going to go through. But there's also the different checks and balances to make sure that you have to have this permission to execute this transition. Only a product owner can approve a feature request for development or something like that. So we end up using a lot of these validators and conditions and post functions within the workflows that we create. So here we went and added a couple of different workflow manipulation objects. This one happens to be a validator. So we want to ensure that the user is actually 21 years old before we go and pour them any beer. I did that by creating a workflow validator. It has a little configuration screen in it that allows you to put in what the age is. So if we go up to Canada and we run the same demo, we can change it from 21 to 18. So everything will still work. All we have to do is just modify the validator within our workflow itself. We don't have to make any code changes after that. And then just like everything else, in order to get a validator to be part of our add-on, we have to go to the SDK and tell it I want to make a new JIRA module, and I want to make a validator. And it's going to stick a little bit of XML into our plugin descriptor. It's going to be a workflow validator in this case. It's going to point at where the actual Java code is that does the work. And then we have a couple of templates as well, a couple of velocity templates that render what it looks like when you configure this validator in the workflow itself. And then the top right corner, you can see there's a little bit of Java code which goes into the particular issue that we're operating on, and it gets the birth date custom field value, so it gets that date field, and then it goes and it does the date math to get now and subtract out the birthday and then validate that that's actually 21 or greater. And then if that fails, the user will get an error in the JIRA workflow. So if you've ever used a validator, it works the same way that they all do. It allows you to execute the transition, and unless this condition is met, unless this data is valid, it won't allow you to continue the transition. So we've finally gotten to the point where you can pour beer, you're 21 years old, or you've selected that you want beer, we've proven that you're 21 years old. Now we need to do the final integration piece, and that is get JIRA to control the beer hardware. And if you remember, the way that the beer hardware works is you just have to call the right URL. So all we have to do is build the correct URL that tells it the type of beer we want to pour and what volume we want to pour, and then make that call to the Raspberry Pi, and that's going to go ahead and pour that beer for us. So we did that with a post function. That way, when you click on a button within JIRA and all of the conditions and validators are met, and you finally get to the end of the transition, then this post function is going to fire, and that's going to cause the beer to actually pour. There are a number of other ways we could have done this. We could have written a listener. We could have plugged into a bunch of other systems. We could have used webhooks. There's a lot of different plugin points within JIRA that we could have used. But the post function is the one that we like, and it's the one that we tend to use a lot for perform some action after a ticket moves into a particular state. And that's kind of that's the purpose of the post function. So we want to be able to perform this HTTP GET to beerme.local is what I've got listed here. If you look in the code, you can see it's actually 10.21.10.227. That was the IP address that the Raspberry Pi ended up getting at Summit. We're running on port 8080, so we're just building a URL there. So you can see the BPA is our beer port app. So we have a Java class which abstracts the HTTP client, which is actually making the REST call. So a lot of times in JIRA and Java applications, you're generally going to make a HTTP client that does the communication with some other REST resource. And we chose to stuff that off into a beer port app class just to keep that abstract and keep our post function code a little bit cleaner. So it just goes, creates the URL, makes that HTTP GET request, which then in turn causes the Raspberry Pi to go and drive its I/O pin on, wait for a period of time, and then drive it off, and that caused the beer to pour throughout all of that. We have our plugin descriptor information down at the bottom. So in order to implement a post function, we have to tell JIRA that we want a post function. There's a couple of templates in there. So again, when we go into the workflow, we can actually configure what the different parameters are, how it's going to operate. And I think that we're doing well on time, so we'll actually flip over into JIRA and take a look at how the workflow is configured and what the post function and validator configuration screens look like that are being driven by these templates. Before we do that, I wanted to just talk a little bit about JIRA add-ons in general. We're not going to go really deep into actually creating a plugin or anything like that, but again, if we have time or if you want to do another demo or something with us, we can figure something out. What you're going to do the very first time you want to write a plugin is you're going to go to developer.atlassian.com. This is the portal for all the development information for developing for any of the different plugins. One of the first pages that you'll see there is how to set up the Atlassian plugin SDK. This is a single software development kit which will give you everything that you need to develop for any of the Atlassian products. So you can develop plugins for JIRA, Confluence, Bamboo, Stash, Fisheye Crucible. It's all in there. And it also has module creators. So once you've created a plugin, then you can create a module for your plugin. So if you make a JIRA plugin, then you can add a web panel and display something within the issue, and you can add in a post function and a validator and a bunch of other different functionality to do whatever the thing is that you want your plugin to do. The really common commands are Atlas create JIRA plugin. So if you're not making a JIRA plugin, put your application name in there, but that's actually going to pop up a little wizard that walks you through the process of setting, you know, the project name and your version and all the other information that goes with it. Once you actually have that, you can then go run Atlas create JIRA plugin module, and that's going to say, okay, I want a custom field, and it will put in all of the stub code and modify your plugin descriptor to give you a custom field. Then you just have to go in and modify the code to make the custom field do what you want it to do. After you've changed your code, when you're in the development process, you're going to use Atlas compile and Atlas package in order to recompile your code or package it up into a jar. Atlas run will actually download a specific copy of any of the applications and run it in developer mode. So you can specify in your, if you've ever worked with Maven, you just modify your POM file. If you've never worked with Maven, there's this thing that's called pom.xml. It's your project object, I forget what it stands for now, but it describes your entire project. So you can list all of the different dependencies, all the different particular ways that you want Maven to build your project. It describes the whole project object model or something like that. So within that, you can specify specific versions of JIRA that you want to run. So when you run Atlas run, it'll download that version of JIRA and run it in developer mode. So if you want to make sure that your plugin works in JIRA 5.2 all the way up to 6.x, then you can specify those different versions in your POM file and run your plugin against all of them. Once you have JIRA up and running in development mode and you go off and you do some development, you can use Atlas install plugin to repackage the, or you'd have to run Atlas package first, but then that will take the jar file that gets spit out from your plugin and install it into the version of JIRA that's running under the Atlas run command. There's some other quicker ways to do it as well. But that's a common way that always works when the other methods don't work for you. I keep saying that you can have the SDK make specific modules for you. This is a little bit out of date. There's actually a number of other ones that you can create with it now as well. But these are the types of modules that the SDK will create all of the stub code and configuration for you. So the component tab panel, and there's an issue tab panel, and there's a version tab panel and a project tab panel. So that's when you go into the project tab panel, for instance, when you go to the project administration, and there is issue types and workflows and field configuration, all those different tabs, you can add another tab to that section with the project tab panel and put your own information in there. Or in the issue tab panel, down at the bottom, there's comments and history and all that stuff. If you want to integrate to one of your own internal systems, you can add a new tab to your issue view and then link that information together however you want. So the way that the JIRA and Stash integrate is when you mention a JIRA issue in a Stash commit, then that whole change set gets displayed in an issue tab panel within the JIRA issue that got mentioned. And it shows you this was the change set that's associated with this particular issue. So if you have some sort of integration like that where you have information that's relevant to a JIRA issue that lives in another system that you have, you can create an issue tab panel to go off into that other system, gather up whatever information relates to a particular JIRA issue, and then display it in that tab panel so people can see how these things are all linked together. There's JQL, so you can make your own JQL functions. If you're creating a custom field, then a lot of times you'll want to create a JQL function. If your custom field acts or behaves in a way that's different from other field types, you may want to be able to search for it differently. Custom fields are really, really popular to make, and they're kind of a double-edged sword. You should always question whether or not you really need to be making a custom field or whether there's already one that's out there. Really the biggest consideration there is that JIRA is already designed and optimized to work with particular types of data packing within the custom fields. Granted, some of them are really goofy, but it's designed to be able to search those things. So whenever you're creating a custom field, you're potentially creating a piece of information that's going to be very difficult to search for. And JQL, the issue navigator, that's some of the most powerful parts of JIRA and one of the things that really sets it apart from other systems. So when you make a custom field, just make sure that you're not doing something that is going to make it difficult to search for that information. All right, we've still got a little bit of time, so I'm going to switch over to the instance of JIRA itself. So here you can see the gadget that we created. I don't think that there's any configuration. There isn't. It just does what it does. If we go over to the administrative side, though, I have no idea what the password is either, so I'm going to have to go figure that out. I'm going to pause my screen for just a second while I get that. Okay, so if we go into the actual workflow that this project uses and take a look at the steps, specifically we want to look at the validators and post functions. So I didn't actually run you through what the system looks like, so we'll open this in another tab and we'll go create an issue. So we're going to create a new request for a back in black IPA. We captured everybody's email address so that we can then go and harass you after Summit. Now I have a new beer request. At this point, what I'd want to do is go and start pouring. And it's going to pop up this screen to warn me, make sure your glass is underneath. So this is our custom field that we created, and all it does is just display that message. So when I configured this screen, I just put my custom field on this screen. Now here for my birth date, I'm going to set it to June 21st, 1981, because I know that's 21 plus years ago. Then when I click on Start Pouring, what you can't see here is I've got the beer rig next to me, and it's pouring a nice frosty beer for me. Sarah just went and poured, and here in our description, it updated to say that we poured 4 units of beer. Now I drank my beer, but I'm not really sure that I liked it. I can't really tell, so I'm going to redo my QA. It's going to pop up this screen again, give me an opportunity to change my birth date. After you've had enough of these samples, you'll go through and change your birthday. So then I just went and poured more beer. And here we can track how many times did we pour the beer, how many QAs did we do. So once I get to the point where I am satisfied, I can go ahead and rate the beer. And then we just have a simple closing screen with just a really simple drop-down list. How much did you like the beer? Now the issue is closed. So we've gone all the way through the workflow. We got our free beer. We enjoyed it. We rated it. So now 21st Amendment has more feedback on their back in black IPA. So we go look at the workflow itself. The start pouring transition has got no conditions. It's got one validator. Verifies the age of the person is at least 21 years old. And if we edit this, so that's the display screen for our validator. And this is what the edit screen looks like. It defines a field name and an age. So we can go change the name of the custom field that we're using, and we can change the age that the person needs to be. That's what the configuration, those velocity templates that define our validator, this is what they're allowing us to do. So they're not really user-facing things, they're more for administrators when they're creating workflows. And then you can see here's our post function, which is set to pour 4 units of beer. Again, this is what the display template displays. If you'll allow me to show you code, I guess you have to allow me because I'm in control. So what the template says is pour $ pour volume field units of beer, and this is a velocity reference to the actual parameter that we're using for the volume. So pour 4 units of beer, and if I go and edit this, then we're going to use our edit velocity template, which allows us to set the volume to be a different amount. So we designed this add-on so that all you need to be is a JIRA administrator in order to modify how much beer pours and what the rules are around how it actually pours. And that's something that you want to consider with your plugins. You don't want to have to go into your code base and modify your Java code in order to make changes to how your plugin operates. As much as possible, you want to offload all of the configuration so that someone that has access to JIRA itself can make those configuration changes. So the flip side of that is then when you have administrative screens or you have administrative actions in your add-on, you want to make sure that you're taking the right steps to actually protect that page so that only JIRA administrators or only members of a certain group actually have access to make those changes. There are all sorts of ways of doing that are already defined for you, and probably one of the biggest challenges with writing these Atlassian plugins is finding the tools that already exist and doing it kind of the Atlassian way. So figuring out how is it that they do it so that you can do it the same way. You can implement your own checks and balances to validate that the current user belongs to a certain group or something like that. But there are easier ways of doing it with decorators and things like that. So I'd like to now take any questions that you have. We've still got I think 15 minutes or so. So if there are any questions, anything about this particular example, or anything about developing add-ons for the other Atlassian tools, I'd love to take those now.
Thanks, Chris. So we already have one question from Ken, and it says, I know the POM XML specifies the JIRA version, for example, but how do I know what to use for the data version and the AMPS version if you change to a different JIRA version?
That's a good question. So this is what the POM file looks like, and as I drive towards answering that question, I just want to highlight a couple of other things here. So when you run the JIRA create plugin script, it'll prompt you for all this information like the group ID, and you want to set this to something that makes sense for you. So we always use com.percipio and then .application.plugins. That's usually where we start, and sometimes we build off of that. The artifact ID is Beer Me Robot, so that's what this plugin is actually called, the version number, there's some organization information. And then this is where Maven starts to get really cool. This is where all of your dependency management is. So here this depends on JIRA, so we just define JIRA. And Ken's question revolves around this JIRA version and then the AMPS version and the other things as well. So here we're defining a variable called JIRA.version, and then down below we set that. We define it as a variable because we use it in a number of places. So for all of the different pieces of JIRA that this thing depends on, this is the JIRA API, and then this is JIRA core. So here by using core, we're using things that are not guaranteed to be stable versus API, which is guaranteed to be stable, but we want to make sure that they come out of the same version of JIRA. So we're using these Maven variables here. So we have all of our different dependency management, and there's a bunch of stuff that we had to add that I didn't talk about, like to do REST stuff, we need this RS JSR 311 API. You just have to add that in, and we're using Google's JSON and Yoda time. So we're using all these different things within the plugin itself to do work. So we just declare them as dependencies, and then Maven will automatically either link them in or pull them into our plugin when it builds, so that JIRA knows what things that we're using and where to actually find them. So specifically to Ken's questions, down here in these properties, we've got JIRA version. So the version of JIRA I'm building against is 4.0.2, and the AMPS version I'm using is 4.2.9, And these other ones don't matter for this particular question, but there are a number of different things that you'll see in the plugin, and depending on the version of the SDK that you're using, and depending on when you actually go and create your new plugin, you'll get different versions of JIRA and AMPS, active objects, all those different libraries. And I don't have a great answer for you, Ken. I've never. It's weird because you can do things like have JIRA 6.0.2 as the version of JIRA you're using, but the data model be 4. I've never really understood what the only reason you need to change your AMPS version or the data model version is if they introduced some big change, and it doesn't seem like, at least for like the data model and AMPS, those things don't seem to change all that often. There's always new versions out, but if you're using the older version of it, it doesn't seem to cause a lot of problems. Mainly where I've run into it was active objects when active objects first came out and was available to use. And at that point, you had to use very specific versions of it because all of them had different bugs in them. And to get the right version of JIRA and AMPS and active objects to all play together, you had to use very specific versions of it. But in that case, I was just going on answers and finding out what magic combination people were using. So I know it's not a great answer, but in a lot of cases, it doesn't seem to depend until it does, and then it's really important that you use the right versions. You just have to hunt around online to figure out what those are. A lot of Atlassian plugin development is hunting around online. So developer.atlassian.com, answers.atlassian.com. There's a couple of other places that you go to look for people that have had similar problems.
All right, thanks, Chris. I don't see any more questions. So I don't know if we want to wait a couple minutes and see if anybody else has another one.
Mm-hmm. And looking at your XML here, Ken, I have always just gone and changed the JIRA version. So even if you change JIRA from 5.2 to 6.2 or 6.x, whatever the newest one that's out is, you can leave the JIRA data version at 5.2, and it doesn't seem to cause any problems. Or you can also update that, and that seems to have no impact too. So whatever it's actually doing, I'm not sure if it might be, actually I bet what it is for like if you're testing your upgrade tasks or something like that. So when you start it up for the first time, the JIRA data version is going to be at 5.2 and JIRA's at 6, so it's going to upgrade it from 5.2 to 6. But the next time you restart it, the data model has already been upgraded to 6, so it's not going to run the upgrade again. So having thought about it, I bet that's actually what's happening. But AMPS, I don't know.
Awesome. So we don't have any more questions. So
Great.
with that, I guess we're done. We look forward to seeing you guys at our next webinar, April 2nd, Confluence and JIRA Integration Primer. And the invite for that should be coming out in a few days. Thanks, Chris.
Great. Thank you, everybody. Have a great day.